So basically, fixed wing operations are nothing but they are like your normal aircraft operations. Only difference between the rotorcraft and fixed wing is that fixed wing, as I said, it is like a normal aeroplane. The aeroplane without pilot inside. So it is an unmanned aircraft. Okay. So what are the fixed wing? Okay, the fixed wing are the aeroplanes which generate lift under the wing due to forward speed, which is produced by either an internal combustion engine or electric motor mounted with the propeller. So either it could have an engine, okay, or it could be an electric motor fitted with the propellers. So there would be a forward airspeed would be generated on it, and it will generate the lift under its wing using the Bernoulli principle. Okay, so you can see they required to be launched. The fixed wing can be launched using handheld or catapult or runway takeoff, and can fly continuously over long distance as opposed to hovering. So these type of drones or the fixed wing drones, they not normally not hover. They will always have a forward motion continuously. So you can see there are different types of drones. The third one, the drone what we see is actually a Predator drone. Okay, the drone which is used by U.S. Army, and this same drone is been now acquired by Indian Air Force as well as Army also. Okay. So what are the types of fixed wing based on their wing type? Okay, so there are straight wings. So it could be a rectangular straight wing you can see here, but they are less efficient because of their shape. Tapered wing, you can see there are tapered wings. Okay, and then there are round or elliptical straight wings. Okay, now if you see with respect to the shape of the wings, okay, the straight wings, the rectangular wings are less efficient, whereas rounded or elliptical. You will see this type of wings in World War I or World War II, where the aircrafts were flown. Okay, you can hear me now. I don't know what I mean. I don't know. I'm sitting in the same space where I was talking.
Mangesh, it's like there's a wind disturbance or something that's happening in the background.
So there is nothing changed at my position. Hold on, let me close the door. Maybe. Now,
Yeah, it's better now.
okay, thank you. Probably maybe because I have left my door open. Probably it might be circulation of the air might have been affected. Okay, no problem. So basically, if you see the type, the rounded corners or the elliptical wings, this we'll see in the olden aircrafts like Spitfire or Mustang and all those World War wars. You'll see this type of airplane, but they were small and all things. This is not possible into the bigger aircraft. But still, you see in the aviation, everything is rounded. You know, right from your tail to your fuselage to your wings, your horizontal, vertical stabilizers. Everywhere there is a not sharp edges. I mean, normally we avoid all the sharp edges. Okay, so in fixed wing, if you see this rectangular, these are all sharp edges. So sharp edges actually creates a disturbance in the airflow. So the more you have a smoother surface, the better performance it goes into the wings. Okay, so that's why you will see the airfoil section also we talked about. Like it should have a curved surface. So the more better curved surface you have, the more better airflow happens. The more better pressure difference will be created, and you will have a much better lift into your wings generated. There are another type of wings in fixed wing which are used called as a swept wings. Okay, these are basically an angle wings. Okay, so slightly swept wing, moderately swept wings, highly so depending upon the shape, it has its own pros and cons, and it has own what we call as control surfaces. Okay, so here you will see that the elevators and ailerons are basically very less control structures are there, but based on their what we call structure, it will give its efficiency or performance in flying. After the swept wing, we'll have called as delta wings. These are very, very high speed aircrafts, okay, especially in subsonic or super subsonics. We will see these are fighter jets or fighter aeroplanes which have been created. So you will see simple delta wing. This is a simple delta wing. Okay, whereas complex delta wing will be have little bit more curved structure, and control surfaces would be more provided to it. So like your B-52 bomber of British of UK, you will have similar kind of structure made of complex
Subsonic means
going
flying below, lower than the
above
speed
the
of
sound
sound,
speed. Yeah, above the sound speed.
above,
Above the sound.
above the speed.
Maybe two times the speed of sound.
Okay.
Like Concorde was moving at the subsonic or supersonic flights. Okay, very high speed. Okay, so let's see what are the parts of the fixed wing. So this is a standard fixed wing UAV. So you will have a wing like a normal aircraft where you will have ailerons. Okay, then you have the engine with the propeller. Okay, attached both sides you will have engine with the propeller attached. Then you have a landing gears. Okay, then you have a fuselage which will be holding your what we call payloads. So you will see the on the belly of the fuselage you will see payloads attached to it with cameras or lidars or thermal sensors. Different devices would be there. Okay. Then you see on the back side you will have a vertical stabilizer. Here, if you see the vertical stabilizer, the tail portion, which has the rudder, but your horizontal stabilizer is not at the tail portion, okay, or at the tip of the tail. It is on the upper side. So depending upon how the drone is been designed, basically they may have designed it with respect to the CG. Okay, so maybe they wanted to keep the tail up and down and whatever other way they want to keep the control of the fixed wing. Okay, so you have a horizontal stabilizer on the top with elevator attached. So what moment we will have if I move the elevator? Any idea? If I move my
If you
elevator,
move the elevator up, if you move the elevator up, the nose goes down.
correct. So it is basically a pitch moment. Okay, so pitch up, pitch down. So you move up, the nose will go down. You move down, it will go up. Okay, whereas rudder will what have the effect on your aircraft?
Yaw, turning left or right.
Correct. So it will be basically changing the headings. Okay, so rudder will make change of your aircraft in directions. So basically rudder is to change the directions. Okay, whereas ailerons will help in doing what?
Roll, roll.
Right, rolling. So it will go give you a lateral movement of your aircraft. Okay, so what are the fixed wing RPS system? So we have propulsion system, fuel system, control system, avionics, takeoff and landing system, and payload. So let's see each component one by one. So what is the propulsion system in fixed wing? Either we can have a IC engines or we can have a electric motor. Now what is the difference by using either brush motor or IC engines? Both required propellers. Okay, so propellers can be connected to BLDC motor or can be connected to the IC engines. But if you see you are using a brush motor, your high power to weight ratio available in wide range starting from 5 grams. Okay, best suited for which type of or which class of drones, that is nano micro category. So using electric motors, you cannot have very big fixed wing drones. You can have small, like you normally use in aero modeling or small operations. Okay, best suited for nano, micro, maximum even small you can go up to it. Okay, low noise help in keeping low profile in stealth operations. That means your here again your endurance is also very less. You will see the difference when we come into brushless motor also. So because these are battery powered. Whereas IC engines, conventionally used system, provide high endurance than BLDC. because your battery might leave you to give you 15 minutes, 20 minutes, 30 minutes. Max to max you can have a 60 minutes. So more battery you add, more capacity you make it, but then your aircraft would become heavier. Whereas IC engine is for higher endurance. That means your aircraft using IC engine or internal combustion engine can fly maximum like 1 hour, 2 hours, 4 hours, 6 hours. Sometimes even the bigger IC engines will give you almost like 24 hours of flight hours. So that's why Predator drones, which are capable of flying almost for 33 hours, because of IC engines. Best suited for medium and large. You see the category because the weight automatically increases because you have an engine which will be always weight, and then you will have a tank. The fuel what we would require to power the IC engine. That tank itself will be weighing, right, almost like 10 liters, 20 liters, or 200 liters, whatever it is. Based on your endurance capacity, you will increase the size of the tank, and based on that, you will design your fixed aircraft. So best suited for medium or large category, IC engines are noisier than BLDC. But IC engines are not flown at like normal drones what we fly, like 400 feet and all. IC engines aircraft are flown at a very high altitude. So like Predator drones, they don't fly at 400 feet only. They are used by defense. They are used fly at a very high altitudes. Okay. Whereas for both the systems, whether it is a BLDC motor or IC engine, you need a propeller because that is what actually is going to generate the thrust. Okay, so connected to BLDC or IC engines, provide thrust rotating in size, particularly direction. Okay, the as it motions, the what we call rotatory motions, it will create a thrust. Okay, these propellers are maximally made earlier. If you see in the older times, you will see this when we go to resort. Okay, when we go to our flying location, we have kept some wooden big propellers in the resort because we had a lot of parts of our vintage aeroplanes since we were into the aviations for almost last 96 years. So we had earlier different types of aeroplanes, and some aeroplanes have got damaged or lost. So we had a lot of components which are there in our Mumbai aerodrome, but some of them we have just shifted to our resort. So slowly we will might be whatever the parts are there, we might just for a display purpose we'll put it into the resort on near our drone this thing flying location. Okay, so made of wood or industrial and small grade plastic or carbon fiber. Okay, we also have a plastic propellers also, and as well as carbon fiber propellers also can be used. Okay, so normally nowadays nobody makes the propeller made of wood. In olden times people used to make it because it's very complex and very difficult to make it because these are all handmade. Okay, so you need a very precise person to make, knowing how to make it properly because both sides should be similar. Okay, so that's why you need a very precise person who's specializing in making this kind of problems. So nowadays nobody uses. It's very simple to prepare a plastic high quality plastic grade propellers or maybe a carbon fiber also. Okay, so that's what about the propulsion. Then fuel system, like if you are using a BLDC motor, you will be requiring a lithium-based batteries. Okay, LiPo or Leons are the most widely used batteries. LiPo batteries can be custom built on different shapes and sizes. LiPo batteries are capable of higher endurance flights, lithium ions basically. Okay, energy density is far less than IC engines. Here, basically, what happens, you can use this for small aircraft and small these things, considering the type of flight what you want to do. Okay, maybe surveillance you want to do or some other. But if you are talking about a longer endurance, you want to fly across the like when Osama bin Laden was targeted, that Predator drone which was flying, it has flown from Afghanistan. From Afghanistan, it came to Pakistan. Okay, and from and that high terrain area, okay, it was flying, and it was controlled by pilots sitting in US and Europe. Okay, so there were people who were actually monitoring the flight of that drone in US or in Europe. So you see how the remote flying was performed. Okay, so basically the internal combustion engine uses a liquid fuel, okay, stored in a tank mounted in a fuselage. It could be a nitro fuel or gasoline or maybe diesel, depending upon what aircraft you are flying. Better thrust to weight ratio than lithium based batteries, because this will give more power, because it has to lift a very heavier weight, because this type of drones, okay, what we called this type of drones, we need a lot of power to this will be normally in a medium or large category. Okay, so in that class you need more power. Okay, so that's why we always use liquid fuel. So that's why you see Predator drone is using internal combustion, not the battery and all that. Because they will not give you that much power to generate. For a small weight to ratio, it is okay. But compared to the bigger drones where the payload is very complex, it has to fly up almost 20,000 height. So there you need a lot of power to reach that height also. You know, drone will not reach up to 20,000 feet until it has been powered by such kind of power. Okay. There are alternative options also which are getting developed. Like one is hydrogen powered drones, and then solar powered drones also. Okay, which can keep on flying as far as the sun is available and stores the energy, solar energy in form of a battery and all the things, and keep on flying. Or maybe the hydrogen powered also. Okay, this is a new concept like we are seeing now. Hydrogen powered trucks are getting deployed in India. Similarly, hydrogen powered drones would be coming. Or probably there could be more. I mean, the kind of the way the development is happening. A lot of people are talking about even the cars coming with hydrogen power, or even trains getting developed using hydrogen power. Okay. So, what are the basic controls? As we said, roll means to move your drone left or right in air. Literally rolling your drone. Okay, so I said roll. Okay, so you have to think from the roll perspective. Whereas pitch means tilt you forward or backward. Okay, so when we say pitch forward or backward, so normally there is in drone we can always do pitch forward and pitch back. But in aircraft you can't do pitch back. Okay, you normally when you say pitch up or pitch down. Okay, whereas throttle means to move up or downwards. So when we say give throttle means what? It will change your altitude of your drone. Whereas in pitch, when we talk about pitch forward, it is moving the drone further away. Okay, pitch back means it is coming towards you, and yaw means you are changing the direction of the drone. Okay, you are changing the orientation or heading of the drone. You rotate your drone clockwise or counterwise, allowing you to make circle or pattern in air. So if you see the remote, do you know which mode do we use when we are using a remote? You'll be flying the drones. Do you know which mode do we use? Any idea?
All.
Huh? Sorry. No, no. I'm saying that there are two modes: mode one and mode two. So which mode we are using? Any idea which mode we are using? Or do you know there is something called mode in which we are actually using the remote control?
Mode 2.
Yes. So we are using actually mode two. So what is mode two? How do you define mode two? So mode two is starts with your right side joystick. Okay, right side. There are two joysticks on your remote control, right? You have a right side and one is left side. So your right side joystick, your what we call that lateral movement. Okay, lateral movement controls your roll. Okay, whereas your up and down, okay, front back motion of your joystick controls your pitch. Similarly, on your left side, up and down motion of your joystick controls your throttle, whereas lateral movement controls your yaw. So this is called as RPTY. Okay, RPTY, like how we call our institute RPTO. Okay, just replace O with Y. So it is RPTY. So it starts with your right hand side, roll, pitch, throttle, and yaw. RPTO, RPTY. Okay. So roll, pitch, throttle, and yaw. So when I say roll, you should know that you have to use your right side joystick, lateral movement. When I say pitch, you should know that you have to use your right side joystick, front and back. When I say throttle, you should know that you are using left side joystick to give throttle. So which will make your drone up and down. Okay, and your yaw motions will be changing your orientation of your drone with respect to the location. Okay, clockwise or counterclockwise. That is called yaw motion. Okay, or the lateral motion of your joysticks. So this mode is called mode 2. Okay, so if you see this, your control system or radio controller. Okay, so channel 1, there are 4 channels, so there are multiple channels on this. This could be a 12 channel or a 14 channel or 16 channel remote control, depending upon what controller you are using. Okay, so out of that, first 4 are important. First 4 are nothing but they are the joystick controls. So your channel 1, okay, channel 1 is roll. Channel 2 is up and down, is pitch. Channel 3, is again up and down, okay, it's throttle. And channel 4 is again lateral motion, is about the yaw motion. So these are the 4 controls, 4 important controls of your remote control. Then there are different switches, different, again there might be a small gimbal control, or a lot of other things would be there on your remote control to control different uh, what we say motors or servos or control systems on the different aircraft. It could be a fixed wing aircraft or a drone, or it could be like, for example, I wanted to like I would give an example. Like I have a drone, and I fixed a box on it, and I want to drop the flowers, for example. Okay, in that scenario, I need to put some mechanism so that at the given point in time, I bring the drone over there, and I open the box automatically. So how do I control that mechanism? So I may have to define some control. These control 1, 2, 3, 4 are basic controls, but then other switches are additional controls for controlling or passing the signals to operate some other devices. Okay, like sometimes you see on the drones or the aircraft, you see those color what do you say color dust which has been spread in the air. So how do you trigger that remotely? So these are the switches which are being used to control those mechanisms. Okay, or even the gimbal. How do you control the gimbal? Okay, you on the gimbal or on the camera or on the these things. How do you control? So these are the controls what we normally use. Okay, so any questions? So this is mode 2. In mode 1, what will happen? The controls will reverse. So your roll pitch, which was on your right side, will go on your left side. Whereas throttle and yaw, which is on your left side, will go on your right side. So that is your mode 1. So somewhere in Canada, I think in US also some people, wherever they are, some places people are found of using mode 1. So it is same thing like what we do, left and drive and right and drive. Okay, so that way it is. So most, I would say 60-70% people use the remote control in mode 2 mode. Okay. Until unless you are found of maybe a left-handed or something like that, then probably you can change the controls. Or you have been trained to use mode 1, then only you can use in mode 1 format. Or else normally people use everywhere. At least in India, I have seen everybody is using mode 2 mechanism. Any questions over here? Okay. So as we are flying mostly the drone, we are supposed to be trained in a manual mode of flying of a drone. But probably like for missions, okay, missions, or probably for critical application of what we say application of the drones. We normally, like for example, I was doing a project in Bihar where actually we were flying the drones near the power line towers. Okay, so initially that was a new, we were doing POC, we were given 100 towers. Okay, we were given 100 towers and we were told to capture the photographs of those towers. Okay, so initially we were using DJI Mavic. Okay, so we were using we used Mavic, we used Phantom also, but we used Mavic because it was a small and we don't want the Phantom go too near, because there was a possibility of electromagnetic induction happening on the drones, and in fact we lost 2 drones because of that. 2 Mavic drones uh, become non-functional because of those. Okay, So initially, when we were actually board asked us to capture the images and this thing, we were actually flying in manual. So, but manual was having a challenge because every pilot has its own way of flying. There was no uniformity in the flying. There was no software available because in agriculture you have a software. There is a software developed called mission planning. Okay, whereas for flying the drone for rescue, because here in agriculture your flying is horizontal. Okay, you are flying the drone horizontal. Whereas when we were capturing the images for the power line towers, it was more of vertical flying, horizontal as well as vertical flying, because we had to capture the images of the tower from all the angles, all 360 angles. So we have to actually start from the ground. We start with the base. Every time the bar is increased, we just keep on flying. Plus, we have to go a little bit closer also to the drone. So when we were doing this manual, there was no uniformity. We were seeing that every pilot has its own way to flying. Somebody was going very close to the tower, somebody was going very close to the power line wires and all that things. Okay, so there was a lot of what we say ununiformity in my data capture or my even video capture also. So what we said, we involved one of the software developer company, and using the mission planner software concepts, we developed a software for flying the drone autonomous. So there are softwares available called, like, mission planner is one of the software which is worldwide used. There is a software called drone deploy kind of software is there. Then there is a software called QGCS is a software. Okay, but out of this, very famous is the mission planner. Okay, this is again a free software, you can download and use it, and but this is only available for Windows as of now. So this is basically a ground control station, basically used for plane, copters, and rovers also. Okay, so here basically you can communicate using your laptop. You put the software and communicate. You set up the communication between your laptop and the drone, and you can bind it, and then you can actually plan your drone flying automatically. Okay, so it will behave like a autonomous vehicle. So whatever the plan you have made into the software, it will fly. Okay, so these are basically useful when you are doing some kind of a activity or some kind of application, like you're flying a drone for agriculture purpose. You're flying a drone for some like you. There are softwares also available. Third party softwares are also available. Mission for and software kind of thing, which actually helps you to capture the images in a structured way, a very precise way, proper way. Every time the drone flies.
Land mapping
Huh?
for land mapping.
Land mapping also, yes, land mapping also, like you need to capture overlapping has to be defined, all those things needs to be defined. There you can't do manual flying, so you need to have a software which will help you to capture the images in a very structured and sequential way. So when we were doing this power line monitoring, we got a company involved with this with the help of the board, and we developed that small software which actually plans the flight plan of a drone so that it take offs, it takes the picture at a regular intervals, and then it was capturing the relevant angles of the photos and this thing. So everything was in a controlled way. So when we are doing manually, we were in a day we used to do somewhere around 5 to 6 towers only, because in 1 kilometer range you would have 3 towers only, 3 to 4 towers max. Okay, not more than that. Again, those towers were spread across different terrains. When it was near the city or village, it was very easy to access in the field or something. But when it was near the mountainous areas, forest areas, and all this, so that time the flying of the drones also become difficult, because reaching to that place and visibility was not there. It was covered with lot of vegetations or trees and all that things near to the towers also. So it was very difficult. Sometimes it was so by having this controlled flying things, we were able to control, and we can control the motion of the drones, have a uniform images, videos, footage, and all that things what is required. And we were able to complete earlier, what I was saying, 5 to 6 towers in a day, we were able to reach from 12 to 15 towers in a day. So that's how the efficiency has improved. Okay, and that's why we are able to cover more number of towers in a day, and we are able to complete our target of 100 towers. Okay. So I will keep on talking about this power line project as I talk more and about in subsequent modules, because that will give you a real scenario to understand, and also other projects what I have done in agriculture, or maybe probably into the surveillance or monitoring the crops and all that things. So introduction to mission planning. Drones may have many functions ranging from monitoring climate change to carrying out search operations after natural disasters, photography, filming, or delivering goods. But their most well-known and controversial use is by the military for reconnaissance or surveillance or targeted attacks. Okay, so basically, mission planning, or this was term has come from the military usage. So we normally used to call mission planning, or planning. Basically, drones were initially used or primarily used by the military for this kind of activities, surveillance, targeted attacks, or reconnaissance. We have seen this in Israel war also, with the Lebanon, as well as Ukraine and Russian wars also, what is currently going. So a lot of times we'll see all these terms coming up. Okay. So if you see the fixed wing takeoff, landing, and recovery system. So takeoff normally either it is sometimes done by the handheld, so you just throw the drone in the air, or you can have a catapult mechanism to launch the drone, or maybe a runway takeoff to land. Okay, takeoff and land. Recovery of these, some drones are like for this predator drones. Normally, again, it will land as like a normal aircraft, but the small fixed wing ring, some are having parachute, okay, or some has some mechanism so that it can roll, or could be a net recovery or a zip line could be there, okay, which will actually capturing that aircraft when it comes into that particular area. Okay, this is how the recovery mechanism of the drone is. Okay, so what are the applications of the fixed wing? Basically, it is used in surveillance, in agriculture, mapping, constructions, wildlife protections, mining. So these are the major where the area you have to cover a bigger area. Okay, the bigger sir, like last year, Gujarat government has used a fixed wing to capture the complete agriculture mapping of the Gujarat state. Okay, so they have flown the fixed wing over the Gujarat state, and they have captured almost for 2 months. They had captured the data, and they wanted to see what was the land covered under the agriculture belt or agriculture segment, and they have set up a unit basically which is actually going to use the satellite data and the drone data to compare the performance of the agriculture over there. Okay? And the other aspects also, like maybe water bodies, as well as the land or the terrain part and all that thing. So basically their vision is much bigger, to control or to have the complete surveillance or monitoring of the district with respect to the agriculture and the other resources, natural resources. Okay, so in that scenario where you are covering a bigger area, you normally use fixed wing. Okay, but if you want to map a small farm, let's say I have a 2 acre of farm, can I use a fixed wing? Is it wise to use a fixed wing? No, right? It will not be wise, because 2 acre area is a very small area. So where I can use a cheaper, it will not be advisable. I mean, I will not get a fixed wing aircraft also to fly, because that area will, the moment it flies, that area will get over also. Okay. So when we are covering a bigger area, larger area, that time we are actually using fixed wings. Okay. But if you are using for a smaller space, you will normally use multi-rotor. So how do you compare? So fixed wing unable to maintain the fixed position, because it is always in a forward direction. Can only fly horizontally in forward direction. Requires hand or mechanical launch, or maybe even the runway. Long average flight times, because it has a longer endurance capacity. Can carry heavier payloads, because it's using aerodynamics, so it can glide, it can fly. Okay, this is actually flying. Okay, this is actually using Bernoulli principle to fly. Okay, great stability in the wind. Again, Bernoulli principle coming into the picture. Generally, higher flight speed. That means it is flying at a very high speed. That's why we are talking about when we are using fixed wing, we are using for a bigger surface areas. Okay, longer surface areas. Okay, like I want to survey almost 100, 200 acres of land. In that scenario, I will use fixed wing. Whereas multi-rotor will use where it is easy to control and maneuver, has ability to hover. Okay, it can take off and land vertically. So these are the some important benefits of the multi-rotor. Okay, but the limitations are limited flying times because based on the battery, it will have its flight time. So it could be 15 minutes, 20 minutes, 30 minutes, 60 minutes, max to max 120 minutes. I have not seen multi-rotor drone more than that. I mean, even 60, 120 minutes is very, very high capacity drones. Okay. They are, again, see these drones, the multi-rotor drones, what we flew, they are not aerodynamics. Okay, because they are not designed using aerodynamics. I mean, you can see Phantom drone more or less is aerodynamically designed, but still it's not that aerodynamically suitable. Okay, it is made stable by using avionics. It's not stable because of the design. It's made stable because of its avionics. Okay, we'll see in future topics. So small payload capacity. I mean, multi-rotor normally you will have maximum what the RGB camera, thermal cameras, or lidars, or maybe your spraying tank, seeding tank, or maybe a payload of 2 kg, 5 kg, 10 kg max. As of now, what we have seen in multi-rotor, they are less stable in the wind because there is no control surface on the rotor craft. There is no control surface. So how you will control the, like if there is a huge gust of wind, so your drone will drift. There is no nothing to counteract. I can only increase or try to manage using the motor speeds. Okay, but still it doesn't have that stability across the high winds and has a lower flight speed compared to the uh, fixed wings. Okay, so multi-rotors are used for specific operations, smaller operations, whereas fixed wings are used for bigger operation. There are limitation of fixed wing that it will always move in a forward direction, whereas multi-rotor has a capability to hover at one particular location. So depending on your application, you need to use type of drone is required, maybe fixed wing or maybe multi-rotor. Okay, so with that we complete our today's module of fixed wing operation. In fact, we were supposed to complete rotorcraft also, but no worries. We will start tomorrow on time and we will be able to complete it. So if you have any questions so far, because I want that rotorcraft is the most important, another most important topic with respect to our training, because under that category we are going to train ourselves. So we need to understand the rotorcraft. So I want you to understand how drone functions, how drone works, how drone flies, and practically also see that when we are going for practicals. Okay. So any questions further on?